Alright, so I skipped over a little bit of the sketching last time. We didn't really want to resize that. Oh, that didn't resize it either. That's a bit silly. It's funny how I do that just as I start the video every time. Alright, we just finished the last one by just showing how to sketch very quickly and not doing it. These system of inequalities, I think it's probably worth our while taking a little bit more time over them. So let's see how we go here. So y is greater than or equal to negative 5 over 2x plus 3. Well, we got the y-intercept. That's 3. So let's put that in. Hopefully you can see that there all right. And then my gradient is negative 5 over 2. So I'm going to go down 5 and across 2. And you're going to see that it's really tricky on this particular drawing thing for me to put a line through those. So let's see if I can cheat a little bit and get a line roughly through those points. Oh, it's not going to let me grab it. Well, that'll do for now. Let's try the next one. We've got a gradient of a y-intercept of negative 1 and a gradient of negative 1/2. So I'm going to go down 1 and across 2. Well, that was fortunate, wasn't it? Because we can see where they cross over. Let's just put the line in as best we can anyway, and you can see, oh, that wasn't so good. Delete that one. Not having a lot of luck. Let's try and put a line in again. I hope you're finding that entertaining. I'm finding it more frustrating than entertaining. I'm going to have to draw it freehand here. That's going to be even worse than usual. There you go. The point where they're intersecting there is at 2, negative 2, which is great if that's what we were after. But what are we actually after? We're after the region that's going to satisfy these. Now, there are two things we need to do here. And I'm going to get my little eraser out and just the small eraser to help me. First thing is we need to sketch the appropriate side of each one. And we need to determine if they're solid lines or broken lines. Remember, a solid line is for a greater than or equal to or less than or equal to. This second equation here, though, y is less than. That needs to be a dotted line. Having a bit of fun there. Because it doesn't include any points on the line. That's all that the dotting means. That's good enough. We can see that. Now, how do we test which side of the line we want? We, of course, test the origin. If I sub in 0, 0 into the first equation here, 0 is greater than or equal to negative 5 or 2 times 0 is 0 plus 3. So is 0 greater than or equal to 3? No. So for that first line, I want the side which the origin is not on. So I'm going to want to the right of that first line. Let's try the second one. 0 less than, that term's going to be 0, negative 1. Is 0 less than negative 1? No. So again, I want the side that the origin is not on. So the origin's above the line there. So I want to make sure I've always got this area below the line. What's the... My goodness, just at the wrong time. I seem to move my hand strangely every time. Alright, what's the region that satisfies both equations at once? Well, I think you'll see it's just this region in there. Satisfying being to the right of that blue line and below or to the left of that green line. That's the section we're after there. Let's have one more look at this sort of thing over here. Okay, I've got my two equations. I'm going to 1 and 2. Let's try and keep our color coding consistent. So that first one I'm going to do in blue. Let's check my intercepts. If I let x equal 0, I'm going to have 2y equals 2 or y equals 1. And if I let y equals 0, I am going to have, that term would be 0, x would be equal to 2. So it's going to go through y equals 1, x equals 2. See if I can draw my line with any more luck this time. Well, it's gone to green, but at least I've drawn it a little bit better. Can I change the colour on that now? Oh, look, I managed to do something right. That's good. So that's my first equation. Let's do the second one in green. And again, the x and y are on the same side, so we'll do the intercept method. If I let x equal 0, I am going to have 2y is greater than or equal to -2. So we're only looking at the equals to draw the line. 2y equals -2. Y would equal -1. So I've got a y-intercept. Y equals -1. Oh, I don't know how I do that. Takes great skill. And the other one, if I let y equal 0, I'm going to have 3x equals -2. Dividing by 3, x equals -2/3, roughly here. So you wouldn't expect to get something like this in the exam where it's not able to be drawn very accurately. We'd usually give you values that are going to go through at least the lattice points, the points where it's got a line to guide you in your drawing. But that's okay. We've got our two lines there. These were both greater than or equal to 1, so that's a nice thing. Which side of each line do we need so we can find the appropriate region? For the first one, x plus y, if I sub in the origin, I'm going to have 0 plus 0 is greater than or equal to 2. Well, that's just not right, is it? So we are going to need above that blue line, the side that does not contain the origin. You don't need so many arrows, you just need one to remind you which side, but that's okay. Let's have a look at the next one. Get my pen back. Where's it gone? There it is. If I substitute the origin, I'm going to have 0 plus 0. Is that greater than or equal to -2? Yes, 0 is greater than -2, so I actually want the side above this line as well. What region does that leave me with? You can see it there already. I think I'm going to shade it in a little bit faster this time. All that region going off into the rest of the plane there. That's the required region. Any point in that area will satisfy both of those equations at the same time. All right, have a little practice with those. Hopefully you know what you're doing. Don't forget to learn how to do them on your calculator. That way you can check your working, or just use your calculator to make sure you get it right. Catch you in the next video, guys. Bye.